Hi, my name is Blake Hament. I'm a graduate student at the Drones and Autonomous Systems Lab at University of Nevada, Las Vegas. Recently, we did a cool project where we built a motion platform and programmed a virtual reality snowboard training game. We thought this was a great project. If you're interested in gaming, virtual reality, or robotics, this might be a fun project for you too.
Alright, so we used out-of-the-box VR components. The HTC Vive, A, our headset the user wears, B, the infrared trackers go overhead, and they're tracking C, the controller that's attached to the top of the motion platform. The Oculus Rift would also work with this setup, and the programming would be the same. Alright, so we're going to walk you through all the pieces you need to build your motion platform.
So the first thing we have right over here is our secondary bases. In between these secondary bases are going to be these 2x4s. They're going to keep them spaced. One base here is where our board is going to be set on. The other base is going to be on the swivel, and it provides some separation so you can turn and you get the roll to be able to work. We have our bungees on the back here. We got 4 of them and they're adjustable. We have our hinges, and next to our hinges we have spacers which space the hinges from the bottom of one of the secondary bases. And then we also have our swivel here. And then
Yep, so 2x4s of various sizes. The ones in the back are really just to give us some spacing between the platforms, so you can cut those to whatever specifications work best for you. We've got these fasteners for attaching our bungees to the platform. And to attach those to the platform we have, they're about 2-inch bolts and nuts, and then some different sized wood screws. This is our base platform, and I think that's it. Let's get started.
So first things first, we have our base here. We're going to wedge a 2x4 underneath one of the sides of the base to keep it at about a 10-degree angle. We're looking at beginners here, so the bunny slope is about 10 degrees. We don't need very much. It's arbitrary, so you can pick whatever size you want to get a different angle, but we're just going to drill it in right to one of the bottom here. So right here we have our swivel. We're going to attach the bottom section here straight onto the base of the board. On our base we have these 2 large holes that line up with these holes right here. So when it's attached, we'll swivel around to these holes and we'll drill straight through the bottom, up through into one of our secondary bases. Now we're going to add the spacer to the top of the swivel right here. But in order to do that, we need to flip this over and drill through these holes here, through the swivel and onto the board. Now that we've finished building the base, it's time to move on to the secondary platforms. First, we'll need to connect the hinges to the 2x4s. We'll use these spacers on top of the hinges to keep the base level on top. We'll connect these 2, and it's important to note that we'll have this connected on one of the bases in this fashion. The reason being is that this base will naturally stop the hinge from moving too far. However, we need to stop this in case we over-rotate in the other direction. That's where this 2x4 will come into play. Now, we'll connect the base to the bottom portion of these 2x4s. And then finally, we'll connect these down here at the base so that our board won't overturn. Now that we've finished assembling both sets of pieces, all we have to do is combine the 2. Just place this on top and screw it in. Last but not least, we need to attach the bungee cords and the fasteners. pre-drill holes on all four corners of both the bottom and the top secondary bases. Simply slide in the bolt, attach the fastener, and then screw in the nut on every single one of them.
Alright, so this page is going to give you some insight into how and why we programmed our virtual reality game the way we did. Basically, we went from force diagrams to these equations of acceleration, and if you look at the axes there, you can see how we've defined our different directions.
We'll start with level setup. So in this level pane, you only need a light source, a player start, and a sky sphere. And the player start needs to be positioned at 200, 0, 110. For the game content, you'll need to create an actor, a game mode, and a pawn. Now you'll need to go to world settings in your level and change the game mode override to the game mode you just created, and change the default pawn class to the pawn you created. All this is doing is ensuring that your content is used when the game starts up. So the pawn is actually the most important part of this project. It represents the player in-game, it controls the snowboard, and it has all of the physics. Inside the pawn, you'll see that we need a motion controller component. This is a general tracked controller component that we normally use for VR, right? So this will work with a Vive controller, with an Oculus controller, or any other VR system for now. You'll also want to add a scene component. So you'll go to this add component and type scene. And this second component will act as our mountain proxy. So all of our physics are relative to the mountain. So this scene component needs to have a pitch of -10. And then you'll add another scene component called board proxy, and this will act as our snowboard component. In Unreal Blueprints, you add variables in this bottom left pane. So you see we have these 3 yellow variables. So this yellow indicators for vectors. So you'll type vector and add 3 vectors. One represents the current player position, one represents the player acceleration, and one the velocity. And then you'll add 3 float variables, one for gravity, one for friction, and one for board response. After that, you'll want to click compile, because this allows us to set initial values for each variable. The gravity magnitude is set to -50, ground friction is 0.15, and board response is 3. Now we're ready to actually write this blueprint. So we're using the tick event, which comes with any actor in Unreal. It's the update loop. So this, in our case, runs at 90 Hertz since we're running in VR. And we want to add first the board control. So you'll see we're grabbing this motion controller component that we added previously. We're grabbing the world rotation, and then we're passing that on to the board proxy. And we're forcing a pitch of -10, simply because the rig is locked at -10 or at 10 degrees. But otherwise, the board rotation will exactly match the controller rotation. Next is the set of custom physics. So you'll see we're just grabbing the board proxy, which is now being updated by the controller. We're getting its world rotation, and then we're passing it in to this math expression node. So we'll go into more details about this equation in the description, but for now you'll see that we're just breaking the rotator and then doing some trig on each component. So we have the sine degrees node multiplied by gravity for our gravity component. We have the sine of our roll, the cosine of pitch, and the sine of yaw passed in. And then for the friction component, we have the absolute value of friction times gravity. All of this is passed into the y component of our acceleration, and y is our forward. So this is actually relative to the mountain. So y is your acceleration down the mountain, and x is your acceleration across the mountain, side to side. For the x component, you can see we're passing in the roll of the board times board response times ground friction. Right, so this controls the side-to-side motion of the board. And here's a constant that it just happens to be necessary for our setup. All of these are tunable. And so we've set the player acceleration vector based on those computations. And then, to calculate the player velocity, you simply add the acceleration to the current velocity. So every time through this tick loop, we're going to compute a new acceleration, add it to our last computed velocity, and set the new velocity. Here we just have a check which prevents the player from going up the hill. So we're saying if the y component, which is our velocity down the hill, is less than 0, you just clamp it to 0. And next is where the mountain proxy comes into play. So we have this player velocity vector, which is relative to the mountain. So we'll start with the x component, which is our sideways component. We're multiplying x by the mountain's right vector. And the right vector is, pointing rightward relative to the mountain. So we're taking this magnitude, multiplying it by the right vector of the mountain, and, making that a component of our actual velocity. And, we're using y times the forward of the mountain. So the forward vector is pointing down the mountain since we've rotated the mountain proxy by 10 degrees, right? And the z component is multiplied by the up vector. We're not really utilizing this at all, but it could be used. So we're adding all these components up, and then we're taking the current actor location and adding that to our velocity. And then the sum of all of these is our new actor location. So running this on tick means that we will update the board rotation, compute a new velocity, and then compute a new player location 90 times per second. Now, before we move on, we need to add a capsule collision component. And all this does is help us with the level tile recycling. We want to make a set of recyclable floor tiles such that a player can infinitely slide down the mountain. Next, you'll want to go back to the main pane of Unreal Engine and then enter the actor blueprint we created at the start. So it should be named something like B floor tile or floor tile. So in the floor tile, it's currently just 3 static meshes. So you can see we have the floor static mesh, which is really the only required thing at this point. So just add a static mesh component, like so. Call it floor, and the location is a bit arbitrary, so you can set it to 477x and -127z with a scale of 10, 93, 0.1. And the reason this is so crazy is because we're using the default Unreal Engine cube and we're stretching it into something that resembles, a floor panel. And for the material, you can leave it at defaults for now. The other two required components are this arrow component and this trigger, this box collision component. So you add these the same way that you've added all the other components. And the attach point arrow needs to be positioned at 971,0, -172. And this box collision component, which will trigger the recycling of a level pane, should be positioned at 967,0, -12, with a rotation pitch of -10 and a scale of 1, 9.5, 1. And same thing, these numbers look crazy because we're using default Unreal meshes. If you're actually making a game from scratch, you might have an artist draw exactly what you need, and then the numbers will look a lot nicer. Next, you'll want to add a new function called getAttachPoint. And this function is just a getter for the attach point transform. So you'll add an output of type transform and then pass the attach points world transform into that output. And we'll use this later in the game mode class. Finally, we want to bind to the overlap event of this box collider. So essentially, every time the player passes through this collider, we want to spawn a new floor tile and delete an old floor tile. So to begin, we just make sure that the colliding actor is a pawn, and then we grab the game mode and call add floor tile. We haven't actually built this method yet, but we will do so in a second. So we call add floor tile, then we wait 2 seconds, and then we destroy the actor. You'll notice that the target is self, so we're actually saying destroy yourself. So the floor is going to ask the level to spawn a new tile, and then it'll destroy itself. So we're essentially recycling these levels infinitely. Next, we'll add that method, add floor tile. So in the game mode, you'll add a new method the same way as before with this function button. Name it add floor tile. And all it's doing is calling spawn actor of B floor tile, calling getAttachPoint, and setting this transform variable. So you'll add this transform called new spawn point. Same as before, this variable of type transform. And what this is doing is saying spawn a floor tile, get its attachment point, and set the new spawn point for the next floor tile. So every time you do this, you're updating the new spawn. So back in the event graph, in begin play, we have this simple for loop from 0 to 9 calling add floor tile. So on begin play of the game mode, we're going to add 9 floor tiles and have an updated new spawn point.